Okay, doxed everyone. Cool. Please, Tyler, go ahead. Thank you,
All right.
guys.
Yeah, thanks. Um, I'm probably the least intelligent person on this call, but I know the Modulus Lab guys. I think we're like 40 feet away from each other right now. Um, so I built and run the program that they went through when they landed on Modulus Labs. But I guess one thing I'm trying to like wrap my head around in this space is like, are there certain things that ZKML can enable that don't necessarily provide the better like backend experience, or where like, oh, the tech makes this like thing better, but where it provides like a 10x better like end user or like consumer experience? Um, I guess this is just like a problem I see across crypto where like I think all of us see the promise of crypto, but we don't really see it being readily adopted. And so, yeah, one of the things I am just trying to spend time on is where are the places where this can be applied, um, that, you know, like fundamentally change the way that someone would be able to interact with this ecosystem. I don't know
I
if
think
there's a, I don't know if there's a good answer for
I
that.
have to jump in because this is actually why I started working on this, was because I think it is the kind of the right solution. Or we're looking for a way to own digital assets and to control smart contracts or control smart wallets, basically control our whatever we have activity on chain using kind of more traditional notions of ownership that anyone can understand, right? That are more like about how we're embedded in society, who we are, where we are, all the things that we could do, right? So after we've met, I often give the example, after we've met and talked a bit, you know, I could tell you, I could say, please send 10 ETH to Emiliano, right? And you'd be able to do that fairly well, you know, maybe not on a video call with deepfakes and stuff, but in person you could do it, right? And so why can't we do that with the, you know, why do we have to use wallets and secrets and everything? And that's just a purely technical problem. And if you think about this kind of ensemble model, like Celeste was talking about earlier, an ensemble of models, ZKML models that are measuring everything about you, sort of where you are, your devices, your, you know, your image and voice and your location history and all this kind of stuff. You could eventually imagine having kind of 10,000 factor authentication where you really have a very high degree of confidence that this is this person and this is the intent they've expressed, and then you execute that intent, and that could all happen in sort of an automated way. Um, so I think that that would be the huge win for the consumer and for ease of use, but it's probably very far off in terms of the technology getting there. And so I think about the problem we have to solve to get there is what are all of the smaller problems we can solve along the way? How do we get that flywheel spinning, so that we build the infrastructure and the models and everything else to be able to deliver that kind of experience eventually?
Yeah, I mean, one of the companies, echoing, I think, Jason's point, like one of the companies that I was personally very excited about like 5 years ago or something was this very cool tech company called Unify ID. And their whole point was like on your smartphone, they would track all of these kind of like personal data points that Jason was talking about. And in their TechCrunch demo, I think on stage, they had one co-founder hand the phone to his other co-founder. The other co-founder walked around with the phone for like a couple seconds, tried to log in, and it said blocked by Unify ID. Like clearly your gate is not the same as that of the original owner, which is super, super neat. Probably the challenge there is then getting the models to run locally, because the alternative then is you ping a server which has all these like biometric models stored on it, and the server has to talk to the chain, and you have to talk to the server, and there's all this indirection. So the ideal here would just be you have all the models on phone, and you can run the models, you can run proofs for the models, and accompanied with every transaction is basically a proof of saying like, yes, this was actually sent by me, and by the way, here is what I want to do. Like no more need for a secret key, no more need for any of that. Yeah.
Well, Corin, folks, you want to add something to that?
You know what? Following up the Jonathan latest statement in the chat, would love to know if there is some, but this is more for machine learning than ZK, a way to understand if two or different Twitter profiles are related to the same person, you know? And using ZKML or these kind of techniques to provide some sort of CBD resistance for,
Oh,
especially recently, there was a discussion of, I mean, we already knew that someone is doing that for, uh, doing civil attacks for airdrops, you discover probably with Uniswap when you use burner account that basically you receive many drops, and so someone is trying to industrialize it. So I think that for, there are many attempts like Proof of Humanity that do a video recording with your wallet address using a transaction chain. There are many approaches that we can debate about the security assumptions and many, many others, okay, that someone is showing off. But yeah, the question for me is in general, let's say, despite the specific protocol, whatever, uh, taking an approach of working backwards, so see which could be the use case and product. How do you think that we can apply this technology to those things?
I mean, this is basically what we're doing. One of the hard problems here is linking it back to reality. So getting some sort of trusted. You need some sort of trusted oracle until physicists figured out how to implement Diffie-Hellman in the laws of nature. And the way we do that is by the shiny little orb that DC Builder just showed on camera. You can still see it behind him on a stand. So once you accept that, and once you get over that hurdle of, okay, we need some form of trusted hardware to hook into reality, then you move the problem to, okay, now we have authentic biometric data. And then you can do all sorts of interesting things using ZKML to process that data in a way that gives users self-custody and is decentralized and trustless and all those nice properties that we want. And this is actually how I got to the field of like ZKML in the first place. It was basically, right now the orb does the biometric processing in trusted hardware, and my question was, okay, what if we want to update the model? Does now everyone need to go back to this orb? And we can solve that with ZKML by basically just signing the raw data and doing all the processing in the user's wallet itself, which solves a huge UX issue for us. And then it turns out that this actually opens a number of other interesting doors. If there is a way, for example, to get reasonably secure authenticated data out of a smartphone camera, then we can do things like, make sure that the user who is about to make a big transaction using this wallet is like facially matches the user who originally created this wallet. So it has a number of like security advantages and UX advantages we can achieve here. I think that's, and then there's like a bunch of other things that we're exploring where you can match biometrics across different things. Like you could match facial biometrics from the orb with facial biometrics that are stored on government digital documents, for example. And it opens up a number of interesting use cases once you have access to authenticated sensor data, basically.
Do you think that, trusting hardware, trusting a device is, could be pretty hard, could be a barrier. Do you think that initiatives that try to create some sort of standard or maybe some open hardware design could help to lower? So basically having people that, build, different version of the same trusted device, and effectively what it does or what could be the architecture, could solve or mitigate some of the trust assumptions that a user may face on, I have to trust. We already trust the iPhone when we unlock it. So it's just a matter of explaining that. But obviously, having some open standard would help in this sense. At least this is my view.
Yeah, I mean, we are opening the standards. The problem is not so much that it's hard for people to implement it. The problem is that you don't know that they actually implemented it correctly. Like, let's say you have an authenticating photo camera and you create an open standard for that.
I see.
Let's say a dumb thing where you just let's say sign a JPEG using a ECDSA signature. Now you want to create some sort of public repository of all the known correct cameras. But how do you gatekeep this repository? Like, how do you maintain a list of known correct public keys?
Yeah,
What prevents someone from?
Definitely. I mean, I understood. Yeah, you cannot attest that I did the physical device as each. I mean,
yeah,
we are like the Heisenberg microscope basically. Where the wave is collapsing in my eye, in my mind, in whatever. So it's the same. It's the same problem that you have in other. But we have some sort of already some scheme about game theory for oracles, where we have a decentralized network of people, entities, agents that maybe have some skin in the game to to attest truthfully something.
Yep.
Isn't something that could solve,
or just traditional trust models, like you just said. We trust Apple to do this stuff correctly when they do it. Like we trust, like if the iPhone through some hoops can produce authenticated images, then we would trust this to be correct, because Apple is too big to mess up a feature like that. Similarly, I think right now either Nikon or Sony, I forget whom, but they also dabble in authenticating cameras. And for the Web3 use case, we trust them to do that correctly, because we basically trust people at Sony and Nikon to not even know what Web3 is, let alone build hardware exploits for their benefit, because right now the opportunity is not there. Problem is that as soon as the opportunities become there and things do get big enough, then people will actually infiltrate supply chains to mess around with this. This is, for example, what is happening with decentralized exchanges. People literally apply for jobs at Verizon and T-Mobile just so they get the authorization to do SIM swaps, just so they can take over accounts at large centralized exchanges using their two-factor authentication. Similar problems, the same thing I would imagine happens once we go to trusted sensors. Like initially it will be all happy because the use case is so small that we don't have to worry about this. And then the value, like assets under management, so to say, will become large enough that it becomes a viable supply chain attack.
Yeah, but I mean, we can spread the risk across, and if we are able to attest, assess in different ways without concentrating on a single, point, basically. The problem for SIM-swap is that single accounts owes too much money that, becomes very, feasible to do that kind of attack. But if we are able to have, I don't remember who was saying, but multiple ways, some sort of multiple factor for authentication. That could be just in the individual, with an SMS or whatever, but also via schemes like, social recovery or social attestation. I mean, I know that Emiliano has that face, not because Emiliano has just a camera, but because Emiliano was in a picture with another guy that I trust, or in a public event or whatever, So I think that probably if we have a framework where we can have all those multiple sources of data with the respective weight for, saying that something is true, it could work somehow, rather than specializing a specific, technology or device.
And this is when you get to the end game of basically just doing full-on Bayesian risk analysis of like, hey, this person is claiming this authorization with this evidence. Like, what is the probability that this is incorrect? And then you say, well, for small transactions, I'm willing to tolerate like a 1% false positive rate, and I'm even willing to like put my money on the line and having to reimburse this person. Whereas for very large transactions, you want maybe higher assurances, and you can optimize for expected value and blah blah. And this is basically what big banks are currently doing, which is why you can get away with so many crappy things that the banks are doing, because they have these risk models and they just know what the trade-offs are. Same thing with Google, and it's like CAPTCHA, where like sometimes it's a simple checkbox, sometimes you need to go through more hoops. It's never really clear why and how, but it's just based on their back-end risk models.
The same thing is true for insurance as well, right? Like people have a higher burden of proof. It's a more substantial claim, which is also like we talk about endgame, like some of this wallet recovery stuff, as well as kind of verifying insurance claims is somewhat like the end game for some of these models as well. I mean, just massive business that can't exist on chain because there's no good like verification of claims. But ML could be one tool.
Cool. We just have, just for the sake of time, 5 minutes. I think that we can, stick over one topic basically, or some follow-up question to this.
Yeah, maybe a question to the group here. Does anyone have a good overview article or just a graphic even of all the different types of ways we can do encrypted machine learning? So thinking about a mapping of FHE, of federated learning, differential privacy, and including ZKML and all its ways and forms. Is there a good like all-encompassing guide for this anywhere? Or should we put it together?
I don't think that there's an aggregator of all those fields. I know that there's some FHE stuff. I've put together like a guide called Awesome ZKML, which like aggregates ZKML stuff. And I haven't seen anything about differential privacy. I haven't looked into that topic, but I'm pretty sure that like you can just create a doc that just encompasses all of these resources together.
Yeah. Okay. I just created.
There's a lot of interesting combinations that you can, where you mix 2 or 3 of these next generation technologies, and you get generally some new capability that you can't accomplish with either of them. So I think there'll probably be a lot of interesting things that come out that combine differential privacy and ZK, or FHE and differential, whatever, right? Pick any 2, and there's some new function you can compute. So.
It's really cool, but the computational overhead you create from this when you combine like technologies like this it's pretty big, like 10,000-fold computational overhead over the computation itself. Just fun.
But computers are so fast, and we can't spend it only on JavaScript animations.
Have you heard that the actual JavaScript ecosystem is actually getting better now? You're using like Rust, TurboPack. It's just like new stuff. It's really fun. It's getting better. It used to be worse.
The disgusted look on Ryan's face. By the way, DC Builder, did you get to talk to the guy from FedML.ai? I think Salman.
FedML, I don't think I've heard about that. Can you send me a link?
Okay, I thought I connected you guys. Yeah, I posted it in the chat.
Yeah, thanks.
So it's a platform for doing federated machine learning. Basically, they created a bunch of primitives. Yeah, and they're also racing a pretty big seed or Series A. I don't know. We can talk about privacy maybe. I learned some terrifying facts about large language models in the ZK Knowledge podcast, Zero Knowledge podcast with Florian Tramier, about how you get basically like private data randomly leaked through GPT-3 or GPT-2 that I had no idea about. Just like someone accidentally posted there, or got I guess doxed online, and then the training data just picked it up and the model didn't transform it. So there's like some people just included in the output of GPT-2 with their full data.
I guess I can speak, like the way these, at least the early kind of like RNN LSTM based models work is that for each input token, you are obviously keeping track of like the state of the sentence, so your context, but basically you are trying to output the greatest probability next token based on your context so far. And you can put attention over this. If you have only attention, then you have a transformer. But the idea here is that if there are very, very unique sequences in the data set, and if your like model dimensionality, so like your hidden state dimensionality is really high, then what ends up happening is the model quite literally just memorizes, because it says, yeah, after this particular sequence of tokens, the only possible next token that I've seen in the whole database, which is not going to give me infinite loss, basically, is this next token. And so it just spits out that memorized sequence. This kind of problem seems to be possibly inherent to just high dimensional model representations in general. I think there's been some work done on like trying to do robustness and like lower bounds on, I guess, like error or something like that. I'm not too familiar with the literature, but it does seem like for these like kind of deterministic complex representation models, memorization might be like an inherent problem. And also there's the whole issue with like querying, right, that Florian was talking about, in which you can almost like reconstruct model weights for smaller models by just querying the model enough times if you know the structure of the model. You know?
All right, thanks. That was very helpful. I had no idea how it works in particular, but that was explanatory. Wish I could make better otter sounds.
Yeah, and then I guess even on the topic of like security with respect to weights, I mean, as Jason has been alluding to, I think multiple times now, like adversarial attacks are really, really bad in the sense that, especially for image adversarial attacks or audio adversarial attacks, you can perturb the input signal by an imperceptible amount to a human and have the model output with like 99.8% confidence, just a totally different classification class, or have it regress basically whatever number you want it to output. And this is basically a consequence of the fact that models are differentiable, and you can differentiate with respect to the outputs in a certain kind, we call it like projected gradient descent way, to kind of minimize the impact, like the human perceptible impact on the input while still changing the output class. And so, yeah, I guess the point is in this case, if you know the model weights, or if you have a good approximation of the model weights, you can conduct a white box attack, which means locally you just run the attack and then you are guaranteed basically that the model will accept it.
And it's one of the things where it's kind of a double-edged sword, because ZKML can fix this problem by letting you hide the weights. It's not like a perfect bullet against adversarial attacks, but it helps a lot. But then you lose out on kind of the Web3 ethos of anyone being able to run the model. So it's, you can hide the weights, but then you need a centralized operator, or you cannot hide the weights, but then you have to deal with adversarial attacks.
Yeah. So like one thought in this direction might even to, I guess, have like non-deterministic models, or maybe models that aren't so easily backpropped through, right? So like GANs, for example, have a sampling step, which you can, I guess, approximate in some sense with like some smooth function. But in general, if we like put enough discontinuities or train models where it's not so straightforward, I guess, like to go from output back to, or to go from changes in input or changes in intermediate to output, then showing the weights might actually be okay.
Are there techniques to make the white box attacks more costly, to where like the profitability is reduced, or where it's sort of a moving target, where you would have to continually recompute a new attack vector or a new attack strategy?
Yeah, so in general, computing an attacked input with some of the state-of-the-art attacks, so based on what I remember, at least, there's this really, really strong attack called Carlini-Wagner, takes like a couple thousand, basically, like gradient descent iterations. So computing the attack is pretty costly, and you can make it more costly by having like a diverse ensemble of models, for example, where an attack which works very well for one of the models doesn't work very well for the others because you are only gradient descenting with respect to one of the models. With that being said, black box attacks are also apparently really good, which is super, super sad. The idea being that you can just train a similar model on effectively the same data set that the model you're attacking was trained on, and get something like only like a half reduction in your attack success. It's just tough. It's quite tough. I guess Florian's point of how many of these attackable models and how many of these attacks are possible in production level models where like the model itself is hidden, you don't really know how like the data is cleaned, if the data is normalized, things like that, is helpful, right? Security via obscurity. But at the end of the day, basically in theory, it's very hard to defend.
I got to jump in a minute, but I just want to make one comment, which is that I think it's important to think about ZKML as just like one part of an overall crypto system, and just like a single piece of a crypto system. If you don't salt your passwords even or whatever, right? Like you can make some mistake in the system that doesn't rate limit people and lets people do sort of obvious attacks. So I think whatever we design using ZKML, especially for security, we have to think about the context of the overall crypto system and how do we put the pieces together to make attacks like this difficult or impossible. Thank you for the discussion.
Okay.
Mic drop.
Yeah, we are out of the time, but also I'm not sure about how much I have for recording, not on my laptop, but via Jitsi. So I think that for this call, we should be very satisfied of the overall result. I mean, at least I think that was so full of content. If you agree, but I think that we can ask also to the Telegram channel. I would love if we can do this recurrently, maybe not every week, but maybe bi-weekly, so every 2 weeks. If this sounds good, we can plan for the middle of November or the second week of November. Do you like it?
Sounds good to me.
Yeah.
I would suggest also starting with a round of intros so we know what everyone's doing and working on.
Absolutely. I had some problem with the webcam, so I have to get back and forth. But yeah, next time we can dedicate half of the of the call, to know better each other. Yeah, definitely. Please integrate the notes that DC Builder share in the chat with yours, so we can publish in the description of the video that we are going to publish on YouTube, and also in some repository for others to see. Okay. Cool. So let me save stopping the recording.